Alright, so this past year at school, I was part of this organization called Make to Innovate. And it functioned as a club, but you still got credit hours, so it's not terribly important. The point was that there were several groups that would each design something that, over the course of a few years, they would develop and build. And the group I was part of, Harbinger, we wanted to design a vertical takeoff and landing craft, or VTOL. Now, we based our design off of the DARPA X-Plane Challenge, which was this, challenge that started 60 years ago to pretty much build faster and generally better VTOLs. Now, the design that we based off was actually taken from one of the original DARPA designs, and I think it was determined that that original design actually didn't work. So our goal is pretty much just to get it to try and, work. So this whole Harbinger group actually started 2 or 3 years prior to this. So my first semester, fall 2014, was spent familiarizing myself with all of the programs we would be using in Harbinger, which was mainly SolidWorks. So me and the other first-year students were tasked with essentially designing our own VTOL. So we had to kind of go through the engineering design process, which I've made a separate video about, and kind of model our design in SolidWorks. Now, the design need not actually work, and given that we were first-year students, we had no idea if it would. We pretty much just needed to get practice with SolidWorks, so we'd know kind of what to do. However, since this wasn't part of the larger Harbinger project, it was more a separate training exercise, I'm not really going to show that. I'm going to focus really exclusively on this second semester, spring 2015. Alright, so this semester, we weren't really designing Harbinger. Harbinger was pretty well designed already. We were mainly wanting to test it to, see how well it would do. And one of the tests we wanted to do was a wind tunnel test, see how much lift it could produce. So what I did is I took one of the SolidWorks designs that people had previously made in Harbinger, and I pretty much fixed it. So I repaired any holes that might have been in there, because they had intake vents and spots for ducted fans, to produce the lift. But we wanted a general kind of baseline test, so I filled all those in, and I also fixed any rebuild errors. Now, I'm going to take a bit of a detour to explain how difficult fixing these rebuild errors was. So, when you're doing a design in SolidWorks, you typically make a sketch, essentially a cross-section of what you want, and then you extrude it. You add depth to it. And you typically do this a bunch, with each future sketches being based off of the previous extrusion. So I have my first extrusion, and then I make another sketch, on the side of this extrusion. So this sketch is now based on the geometry, and thus relies on this first extrusion existing. The first extrusion has to be there in order for the sketch to be fully defined. And then I make an extrusion from that, and I continue on and carry on. Now, a rebuild error is when you delete one of these original extrusions. So let's say I delete my first extrusion. Well, then my second sketch doesn't have the geometry it was based on, and so it doesn't know how big it should be. It doesn't know what size it should be. And so it, stays in the general form it was, but SolidWorks is kind of don't exactly know what's going on here. I don't have all the information. So there's an error, and when you try to make something, because SolidWorks is intended to 3D print out items, and make generally three-dimensional designs of the things. So when you try to make the three-dimensional design, actually a physical copy of it, SolidWorks might freak out a little bit and it might mess up the design completely. So you need to fix these rebuild errors. The thing is, to fix these rebuild errors, it's very difficult. You typically need to go back in and recreate the original extrusions. However, since I was basing this off of a design that was already made and had been saved a while ago, I didn't have the original extrusions. I couldn't just click undo and get back the original extrusions, so I kind of had to go back from scratch and recreate them. So the method I went about to do this was I would take the sketches that we wanted, because the extrusions were typically just baseline stuff, so we would know where to put the sketches. So what I'd do is I'd take the sketches we actually wanted, and the sketches were typically made up of a series of points. So it would be a point here, point here, point here, point here, essentially almost a connect the dots type thing to make the cross-section we wanted. So I would figure out the coordinates of pretty much each of those points, with respect to the origin, which was a established thing in the SolidWorks program. I would figure out the coordinates of each of these points, I would record the coordinates of each of these points, and I would then go ahead, delete the sketch, and then I would recreate the sketch using the coordinates I'd marked down. So now this new sketch wasn't based off of any previous geometry, it was based off of the coordinates I typed in. So it wouldn't have the rebuild errors. This is a tedious process, as you might expect, having to mark down and then retype in all the coordinates for the sketches. And there were a lot of these rebuild errors, like 30 or so. So it took a while. Now, if you didn't follow this, it's not terribly important to the larger project of Harbinger as a whole. I just really kind of wanted to emphasize the trouble I went through to fix this SolidWorks design. Now, after I had the SolidWorks model done, we sent it off to this lab at Iowa State, my university, to get it cut out of foam. Now, unfortunately, I'm not part of this foam cutting lab, so I wasn't able to get it on video, but still pretty cool. We got it cut out of foam. Then we went to this other lab, also at Iowa State, where we had it tested in a wind tunnel. Now, the little tidbit, we were actually the first Make to Innovate group to use the wind tunnel. Not the first people ever to use the wind tunnel. Other people have used it at Iowa State, but we are the first Make to Innovate group to use it, so it's pretty neat. But anyways, we mounted it then to this sensor using this plate that other team members in Harbinger had designed. And then we tested it in the wind tunnel at various wind speeds and angles of attack, which is just the angle with respect to the horizontal, in our case. And we measured its lift based on the force that it would exert on the sensor. And it was a pretty big wind tunnel. I mean, it was a big room, but it still took up a decent chunk of it. You could very easily stand inside the wind tunnel. So it was pretty cool. However, the test was a little weird, because at like angles of attack of like 30 degrees, we got lifts way higher than what we should have. So we're guessing this is a case of us messing up the test somehow, rather than just us being super engineers and designing a craft with fantastic lift. So it's unfortunate, but at least we have a general idea of the lift, and I think we were able to correct for those errors, so at least we have a general idea of how well the craft can do, and plus we got to use the wind tunnel, which was pretty cool. Now, aside from tests, we also built some components for the larger full-scale version. Because right now we have a prototype, and I'll get to that in a bit, but the end goal, at least the original one, was to build a large 2.5-ish meter wingspan, which is about a person and a half. So for that, we built this internal frame, which we marked a bunch of the components to, like the batteries and the motors and all the electronic control equipment. So we have the internal frame for that. And then, well, this was technically at the end of last semester, we have the fan, which will produce thrust. Now, there will be officially 2 of these, but we only had the funds for the one of them. And then we also bought this purple motor, also at the end of last semester. It's fairly heavy, but it's got very powerful, so trade-offs. And then another thing we had is we have this duct, which was also cut out of the foam lab. And it was actually cut into 3 separate pieces, which we then glued together, and then we sanded it and, you know, used putty to fill in the holes and sanded it again. It was a fairly tedious process, which unfortunately I didn't get video of, but we did do that. I did, however, get video of us using this hot knife, which is just a heated knife, to cut through the foam to make these little notches so we could mount our motor. Now, the motor we ended up using wasn't the purple one that we wanted to use. I think we weren't given permission for it or something like that. Honestly, I'm not entirely sure. So we had to use this other motor that they gave us, and then we pretty much bolted it to these metal beams, and in turn we then glued the beams to the duct, and then we bolted the fan to the motor. So it's all connected. We have our duct fan motor setup. So this is ideal for fan testing. Now, before I get to the fan testing, I want to go back and look at the prototype. So this here is our prototype, which is pretty much just a test bed for us to kind of work on the program with it, the controls. Because while it will be more controlled, at least initially, we do still want like reaction control mechanisms. So like if it starts to tip too far one way, we kind of have it, you know, correct for that and adjust it so it doesn't, you know, flip out and spin out of control. So this is essentially just a test board for that. And the thing we're working on this semester is trying to figure out, or develop the code so we can go from hover mode to flight mode, which is arguably the most difficult thing to do. So we made some modifications to the prototype. We attached servos to the 2 front propellers so they can rotate forward. We're pretty much just trying to figure out how to get it to do that transition and develop the code for it. And we did do a test for it where we attached it to a string and tried to have it go from hover mode to flight mode. However, it didn't work. Like, for whatever reason, the code just wouldn't work. The program stopped. The propellers wouldn't turn. The servos worked, but the propellers wouldn't activate. We're not entirely sure why, and that's something that we're going to look at and hopefully figure out next semester. However, the prototype is not what the final design will look like. Rather, the final design will essentially be the general shape. It'll be bigger, but the general shape as the foam cutting model that we used in the wind tunnel. But the fans, the ducted fan system that I showed earlier, will be placed in the wings, one in each wing, so that way they can rotate and create thrust that way. But we will also have a counter moment fan just inside the body near the front to kind of add stability in hovering. And if needed, also in flight mode. But so that's what the general final design will look like. It's kind of a vague description, but I don't have any solid evidence to show you to describe it, unfortunately. Now, the last test we ran was the fan test, which was intended to determine how much thrust our ducted fan setup could produce. So we started out, we kind of connected everything, mounted it, and then we ran one test. However, the fan and the duct were a little too close, and they, well, intersected. It startled me a little bit. So we took some of the duct off, reset it up, connected everything, tried it again. However, the fan and duct were still a bit too close, and, well, it happened again. So we eventually decided to just take the entire duct off. The original intent of the duct is that it's supposed to direct the outflow, so we have more, directed flow, not just everywhere, while unaffecting the intake. So we essentially have intake coming from all over, but we have a directed outflow, which should increase the thrust. However, the duct and the fan kept intersecting, which we don't want, so we decided to remove the duct and test the fan by itself. So we set it up, tested it again. However, we noticed there was a bit too much torque on it, as you can see by this bending, so we had to, again, stop it and brace the fan a bit more. So we finally ran it again. However, for whatever reason, it just stopped. We weren't sure why, it just stopped. So I was like, alright, so we just tried it again, kept going, and then we figured out the reason.
Oh, the fried ESC.
Yeah, the ESC, or electronic speed control, apparently overheated and burnt. So we went till it broke, literally, and thus had to stop. I do believe we got some good data. We didn't get as much thrust as we were hoping, but we still got decent thrust, and I think if we had a better ESC, one that was actually fit for the battery, we would have been able to get the amount of thrust we needed. So that was at least nice. But yeah, so that's what we've done in Harbinger this semester. Now, mid-semester, we did have a design review, which is pretty much where we present what we have done since we last presented, to kind of, give them an update on our progress. And the design review didn't go well, really, at all. So we kind of have to refocus what Harbinger is doing. I mean, we're still going to work on the VTOL and try to get it to work, but we need to have a better end goal than just getting it to work. So, aside from fixing the technical issues with Harbinger next semester, we also need to reevaluate what we want to do with Harbinger next semester. But, nevertheless, hope you enjoyed it, and see ya.